Hello, and this is a quite a delayed presentation from my side, Tujashu, from Tujashu's world, right? So, uh, in this particular video, I would like to show you something that is very evident and very trivial. That is, most of you have learned and worked upon Calloc, Malloc, and Realloc with respect to the C programming. But now, what is not very evident in the YouTube or video that is available on the internet is that you can't really see that how this Malloc and Calloc can be done in an MSP430 simple microcontroller, that is a G2XX series, that is a value line series from Texas Instruments, right? So today what I will be doing is I will be showing you a very simple way of allocating some kind of memory into the heap of Malloc and Calloc, and thereby you'll be able to see the memory allocated area that will be allocated to the particular heap, and you will be seeing the value that you will be putting into those particular Malloc and Calloc areas. Now, let me give you a very brief about Malloc and Calloc. Now, it's totally out of the scope that I would rather describe what Calloc and Malloc is. Just this much, that like Malloc and Calloc, both of them are dynamic memory allocation systems for any kind of high level programming as far as like C is concerned. So what you do is mainly you allocate a dynamic memory for storing some kind of variables. Now, the first thing that you must know is that when you are doing Malloc or Calloc in MSP430, G2553, or any kind of G2XX series family, is that you have to go to the properties, right? And you have to change this value. By default, I repeat, by default this value is very low, which doesn't allow you to allocate any kind of memory in the malloc, or it doesn't allow you to allocate any kind of dynamic memory. But if you make it 100 or something like that, well, for me 100 worked. You can try some other values as well. So you should increase this value, which is the heap size of for C or C++ dynamic memory allocation. Now, once you've done that, you can really, what I have done is I have just simply imported a blinking LED routine or blinking LED program into my MSP430 G2 launch pad. And what you need to really call is the stdlib library. Just remember that alloc.h or memory.h will not function here, because it is highly and heavily compiler dependent. So it's better if you just call stdlib. Now here what I have done is, let me explain to you. I have declared a pointer p, which is of the type data type integer, and I have written malloc, that is I have dynamically allocated some memory, and I have allocated 5 such memory areas, as we know that malloc can allocate memory areas of a given data type in the heap area. So I have declared 5 memory such areas into the heap area, and the data type is integer, right? So here goes the particular format. Now, one thing you must remember, that is malloc will always return you a void pointer which points to the memory area where your memory is being allocated, so that you cannot feed back into the pointer, that is p, right? Now the question is that why do we need to feed it to a pointer? Because unless and until you feed it to a pointer, you cannot really deal with an address. So we need to do this particular memory um, typecasting or data typecasting into the integer, that is in star, so that we can convert it into the integer format and feed it back to the pointer. Now after doing this particular line, what I do is I have simply fed some values into the pointer memory areas, that is P0, P1 and P2. I know that I have declared 5 areas, but I have not used 5 of them. If you want, you can use. And then what I have done is, for P0 I have fed the value 1, P1 as 2 and P2 as 3. So basically what it does is it feeds a value of 1 into the pointer area 1, or the pointer location 1, pointer location 0, pointer location 1 as 2 and pointer location 2 as 3. Now let us run the program. Now for MSP430 G2 Launchpad, you can just connect it and just download the program from this particular debug thing. And here I am downloading the program, and after downloading the program, what I want you people to understand and see is that you just look into the thing, that is, what are the memory areas that has been allocated by using malloc, and which has been shown in the expression window as ampersand p0, ampersand p1 and ampersand p2. So that is the reason why I would like to halt the program over here. I hope you can see over here, right? So I just run the program, and here you can see it's a beautiful thing. This JTAG is wonderful. It shows you that 0204, 0206, 0208 are the three memory areas which has been allocated as your dynamic memory allocated area in the heap, right? So now what we do is, now as of now we have not put any values into the dynamically allocated memory areas. So now I want to put the values of P0 as 1, P1 as 2 and P2 as 3. So I have put a breakpoint before free. So now let me see if the values which I have put goes into the memory area, and it is true. That is, P0 is fed with the value of 1, P1 is fed with the value of 2 and P2 is fed with the value of 3. So the values which I have put over here has been fed into the pointer memory areas. Now the next point is that I would like to free the memory area. So for freeing the memory area, what I need to do is just to write the code or call the function free, right? So I call the function free and your memory area is freed. So now when I have freed the area, you can see that the values which has been allocated to the particular pointers, that is in all these three. I try to show it. Anyways, for P0, P1 and P2, they have changed, right? Now what I want to show you is that calloc. Now calloc, as we know, is a particular memory allocation function, or not a function, or is a method where you can, it's the same thing as malloc, but here the argument type is different. As you can see over here, that in calloc, instead of writing 5 into the memory number of areas, I have just given 5 comma the size of integer. So the argument type is a bit different for calloc. So for calloc, I have done the same thing, and I have put it into the pointer pt. Now you would ask me that why did I free the pointer p? I would show you right now that what would happen if I did not free the memory areas which were not there. So let me now just put into calloc, and let me tell you one more additional feature of calloc is that calloc uh, when calloc, when it when it allocates some memory area, it initializes the value at the memory area as 0, which malloc doesn't. So just to show that, I just make a breakpoint after running calloc. So here you see, in calloc all the values in the memory area has been initialized as 0. I hope you can see that, right? Over here, right over here. So in P0 it becomes 0, in P1 it becomes 0, in P2 it becomes 0. Now when we have initialized as values in P0, P1 and P2 as 10, 20 and 30, obviously the values will become 10, 20 and 30. Now the basic thing that you need to understand is that a malloc will obviously allocate an area in the heap, even in case of an embedded system, because I have seen a lot of video where they lead to the particular to a particular tutorial where they are simply either dealing with a computer based system or a hi-fi embedded based system like Raspberry Pi, but nobody bothers to cater to a very simple microcontroller system like MSP430, where you have a very low memory of around say 16 KB of internal ROM, and maybe you have 512 bytes of internal RAM. But you can do calloc and malloc over here, and even realloc. So now the question comes that why did I go for the free? Now if I had not done free over here, suppose, let me now do one thing. I will just block free, right? So that blocks free, and I will download the program into the microcontroller. Now let's see what happens. Okay, so here we can see that the JTAG has downloaded the program into the microcontroller, and here what I can show you is that uh, we are mainly interested to see that what happens if we don't free the memory area, right? So that is possible over here. So first we see when we malloc or allocate the memory. So as when we allocate the memory, we can see that 204, 206, 208 obviously integer are of 2 bytes, so they are allocated, and you see the values 0, 20 and 30. They are random values. Only 20 and 30 were not erased as we had fed them in the calloc. But if we do not free the memory area and then we go back to the calloc area, we see that they have been totally filled with the values that we have put in the malloc function after the malloc function. So freeing the memory area is very important, because if you don't free the memory area, two problems can occur. One is that if you don't free a memory area and try to read the values from there, then you might get a garbage value. Suppose like if we don't fed all these values over here, right? We are not feeding any values and we are downloading this function, right? Let us see what happens. Now, I would suggest you that this is strictly a tutorial, as I said in my website, that it's strictly a tutorial corresponding to a Texas Instrument platform. but I guess this is same everywhere, so you needn't bother. It'll be same everywhere. Now what I do here is I write malloc and I allocate integer memory, 5 number of integer memories in the heap area, and I typecast it as integer so that I can feed into the pointer. Now I do not put the values of p0, p1 and p2, right? So now what happens, let me see. Now when your value, or when your pointer, or when your JTAG reaches this particular area, it really doesn't know that what memory area that has been allocated. It's clueless. It's clueless because see, p0 you can't find, p1 you can't find, p2 you can't find, but at the same time, and I've also not freed it, right? So after the calloc also, since I've not freed the area, it cannot really find that what are the values that has been loaded into the particular memory area. So, my friend, the most important thing that you need to remember is that when you are allocating a memory area using the malloc or the calloc function, you must free that particular memory area, because otherwise if you're not freeing the particular memory area, it will contain garbage data or some previous data, and that will only add on to your problem. So here is a small video of how you can use calloc and malloc on G2XX series of MSP430 family of microcontrollers from Texas Instruments. More will be coming up on some additional or maybe higher versions like the ARM Cortex M4F processor, where you can fully utilize the calloc and malloc function because you'll be running an OS or an RTOS over here. And one more important thing that I would like to tell you is that if you really like my video, or if it is helping you in any way, please do subscribe and like my videos, because that will help me get some more energy to produce more videos which will help you you know in your future knowledge enhancement. So thank you, and thank you for watching this video at the Jashu's World. Bye bye.